Good day. My name is Jamichael Panzalan, and today I will discuss the secure hash algorithm. SH1 Secure Hash Algorithm 1 or HN1 was developed in 1993 by the US government's standard agency National Institute of Standards and Technology or NIST. It is widely used in the security application and protocols including TLS, SSL, PGP, SSH, and IP security and SMIME. Types of secure hash algorithm. SH0 and SH1 is 160 bits hash function, while the SHA-224 and SHA-256, SHA-384, SHA-512, and SHA-512-224 and SH-512-256 is under the SH2 and the SH3 since 2021. What is use of SSH algorithm? All the SSH algorithm is iterative one-way hash function that can process the message to produce representation called message digest. Secure hash algorithm, also known as the SSH, are family of cryptographic functions designed to keep data secured. It works by transforming the data using the hash function, an algorithm that consists of bitwise operation, modular additions, and comparison function. SH1 works by feeding a message as a bit string of length less than 2 to the power of 64 bits and producing a 160 bits hash value known as a message digest. There are two methods of encrypt message using SH1, although one of the methods saves by processing of 64 32 bits words. It if it's more complex and time consuming to execute. In the simple methods example, at the end of the execution, the algorithm output block of the 16 words where each word is made up of bits for a total of 256 bits. Suppose the message ABC were to be encoded using HH1 by the binary for ABC is 0110001, 0110010, and 0110011, and the hex is 616263. The first step is to initialize 5 random strings for hex characters that will serve as the part of hash functions. For the H0 is 67DE2A01, H1 is BBO3E28C, H2 is 011EF1DC, H3 is 9293E9E2, H4 is CDEF23A9. Message is then padded by appending A1 followed by the enough 0s until the message is 448 bits. The length of the message is represented by 64 bits is then added to the end producing a message that is 512 bits long. The padded input obtained above M is then divided into 512 bits chunks, and each chunk is further divided into 16 30 bits words W0 to W15. In the case of ABC, where the only chunks as the message is less than 512 bits total. For each chunks to begin the 80 iteration I necessary for hashing 80 is the determined number for SH1 and execute the following step each chunks MN. For iteration 16 to 79 where 16 is less than or equal to I less than or equal to 79, perform the following operation. Per XOR R represented by the following comparison of inputs X and Y. Now the circular operation S and X on the word X n by n bits and being an integer between 0 and 32 is defined by where X equals where X less than n is the left shift operation obtained by discarding the leftmost n bits of x padding result with n zeros on the right. X greater than 32 n is the right shift operation obtained by discarding the rightmost n bits of x and padding the result with n zeros on the left. Thus Sn x is equivalent to circular shift of x by n position, and in the case the circular left shift is used. So a left shift is with Wi, where Wi is 10010 will produce 01001 as the rightmost bit 0 is shifted to left side of the string. Therefore, W16 would end up being 11000010, 11000100, 11000111, and 000000000. Now, store the hash values defined in the step 1 in the following variables. For iteration where 0 is less than 79, compute temp equals to S5 times A plus F I B C D plus E plus W I plus K I. Store the result of chunks has to overall hash value of all chunks as the shown below and produce to execute the next chunks. As a final step, when all the chunks have been processed, the message digest is represented as the 160-bit string comprised of the OR logical operation V of the 5 hash values. H equals to S128 H0 V S96 H1 V S64 H2 V S32 H3 and V H4. So the string ABC become represented by the hash value akin to A999-3E36470-6816A BA3E25717-850 C26C9CD0D89D.